So today, I'm going to talk about system design interviews, and more importantly, how to prepare for them. Actually, more importantly, how can we get better prepared for them? And just a quick show, who is into it, who's been doing it on either side of this table. What's been your experience like? What's your general experience like on this? Like, you interview enough, interview too often, interview once in a month, once in 6 months? Been a while? Okay.
We used to practice it a lot.
Practice helps. Practice makes perfect. Yeah. So this is not exactly about how to prepare for it, but more about what tools we can use and how can you, like, how I thought about improving my game and what I could do to help others, right? I'm not selling a course. I'm not selling any subscriptions to any blogs or anything. That's not my thing. I'm a builder. I like building tools, and thought I would share something I built. Bit about myself. I've been an engineer for a long, long time, as far as I can remember. I came to the US from Australia about 12 years ago to work for one of the big tech companies. Worked on many large-scale systems, on data processing and infra. Managed teams, hired them, obviously interviewed them, and my experience is around looking at the systems in a very analytical kind of way, right? And from an interview perspective, I've conducted plenty of interviews. I've been on both sides of the table. I've seen a lot of kind of personalities and how they play out and failure modes, and best of all, I've failed myself many times. So what better than learning from failures, right? So first of all, this talks about design interviews. We'll give a brief intro on what they are and what people are looking for and so on. But more importantly, we'll see how we can learn by building, right? And I built a tool called SDL. In computer science, naming is one of the hardest problems. SDL very boringly stands for system design. I'll leave the L to your imagination, right? And look at some concepts, look at a simple demo. There's a lot more to be done. This is still V0.01. So feedback and help and criticism, absolutely welcome, right? Why design interviews, right? Because all these companies, they have so many bespoke systems internally. They've grown from the MVP days, and they've gradually built up over the years, right? Take Facebook, take Google, take Amazon. They did not start off the way you see them today. They were running on somebody's PHP server, on a couple of databases, on a rack, on some telco that was providing some space to them, right? And they grew from there, right? So, and the consequence of that is that today, when they interview candidates, they have pieces in their stack that are thousands and tens of thousands of different things, right? From at every part of the stack. So what they really want to see is candidates who are very generic in how they think of problem solving. Unless you're a brand name like Kelsey Hightower, who's the guy who created KTOS, right? Or was instrumental in popularizing KTOS. We're all part of the same generic kind of pool, right? So the expectation is how can you be adaptable and moldable and go from there. Just like lead code is used for coding interviews, where they want to see very general problem solving. Design interviews are about that. It's about, hey, how do you scale a system that you don't know anything about, and think of first principles, right? How do you? It's kind of the modern evolution of that, counting the number of golf balls in a bus problem that you had many years ago. The other thing is, a lot of system design interviews are actually an act of communication and time management. Many candidates, myself included, have gone into this mode where, hey, design X, and I'll jump into showing off my technical, taxonomy knowledge, right? Caching, shouting, this, that. And they really want to see, look, we know all that. Can you go through step by step? And then there's aspect of strategic thinking. These companies did not start off by having 10,000 data centers across the world serving a billion QPS, all the time. So they want to see if you can start small, but still have this large vision in mind and work backwards, which means you have to think incremental and go from there. and yeah, so they want to see, how can I think of systems, how can I think of reliability, how can I think of the business. If there's a failure in your system, how does it affect the business? Can you kind of draw that line out? You don't need to be a CFO to understand why something is that costly or think about ways to invest, but you need to have that kind of sense about, in a sense, beyond just the technology, right? On how what you're building today can have implications in what to build, where to build, how to form teams around what you're building, how to support it, and so on, right? So all this kind of comes into play. All that's great for the company, but what about you? What about us? I mean, it's great that companies want this, but we are ultimately the one, going through those interviews and putting ourselves through that trial of fire, right? And I know that when I'm standing there, it doesn't matter how many interviews I've done, I'm nervous, right? I might see a problem that I've never seen before. I might come across, it's just a bad day for interview. It's a bad day for me, anything can happen, right? So, and candidates fail, right? For better or worse. Some fail because of lack of experience. If you've never built a large-scale system, then, without any judgment, you're not at that staff principal level. You're kind of starting out in this area, which there's no judgment there, right? And the other thing is that when you study passively, when you're reading a lot of books, there's tons of great material out there, and I've used them, but passive reading gets you only so far, right? I can tell you, hey, a database can handle 10,000 requests per second. Cool, right? What do you do with that, right? And then there's this, I think sorry, what was your name again? Jared. You just called out, Jared? Jared, he called out practice. Practice is one of the most important things in interviews, right? In design interviews. And having that feedback loop, having a mentor kind of guiding you through that is invaluable. And then just, not knowing scenarios gets in the way. And finally, nerves. I, unfortunately, cannot help you with nerves. I'm not a, psychology guru. And if you have any tips, I'll take it, right? Yeah, so again, binging on YouTube, time-consuming, it's a consolidated brain dump. It doesn't help me. If you're good with it, good for you, right? But let's look at a simple example first, right? I think everybody's seen this example, a Bitly example in an interview. You're designing a URL shortener. For those who don't know Bitly, it's like a tiny URL. It takes a large URL and it condenses it into a 6-letter or 5 or 10-letter URL, right? It's easy to remember, easy to share, easy to tweet about with your limited characters. And it has 2 APIs. You take a large URL, you shorten it. And then when I give it to somebody, they can use that URL. They can go in the browser, put that URL in there. It'll take them back to the original URL. That's the redirect API. Pretty straightforward. User gives you URL, it puts in a database, looks up. There's a user flow there, right? Pretty straightforward. There's obviously a lot more infra behind this when you start scaling and doing analytics and doing custom URLs and fancy URLs and tracking and so on, but we won't worry about that now. That's a system. That's a very simple system. User comes in, calls one of the URLs, writes to a database. Now what? In a typical interview, the interviewer might say, look, let's go into this, see where things are going to fail. How do we scale? What needs to happen? Why? Talk through things, right? So candidates might end up saying, look, database is a MySQL database. On a 4 CPU, a gigabyte of RAM machine, we can serve 10,000 QPS, right? But if you have more writes than reads, we have an asymmetry on the kind of reads, on the kinds of pattern that our system's going to see. If you're going to be writing more than you if you're going to be reading more than you write, then you are unnecessarily putting locks in the database. There's a whole bunch of things you can talk about here, right? And this is where where do you go from here? Like, you can talk about this by reading blogs and memorize it and dump it there, or if you actually built Bitly in your past life, you can talk about it. Now, it is 2025, and you can't have a talk without Gen AI. I promise you, this is not about Gen AI, though, right? So I tried that, by the way. I tried this prompt in Gemini, which is not an open source model. And I picked that because I wanted to kind of see where the leading models were, right? And this is not a diss about open source models either. So I took this, and Gen AI is fantastic at a few things, right? It gives you system diagrams. Right? You can tweak it. You can tell them, look, I don't want to worry about API services. I don't want to worry about X, Y, and Z, and give me this diagram, and it'll give you a diagram. Claude will even give you an SVG diagram that looks pretty. Yeah, good, cool, right? It gives you a description of the flows, what we had in the 2 slides before. It gives you that. It tells you a user comes in, does this, here's an API, they can do this, they can do that, and it tells you what happens. Perfect. And by the way, as candidates in an interview, we will talk about this, right? And this is more about how you would build a system. It can give you some kind of plots. Here's where I'm starting to see the stress, right? It gives you some scenarios, and it had 3 more scenarios, by the way, where if you have certain kind of load, what happens? This looks right, I think. Does it? It's not a quiz. I don't know if it looks right. It tells me it's right, so I'm gonna go with the face value here, right? It feels right. Like all things Gen AI, things feel right. They feel fuzzy and warm and good, right? And here's where I kind of get stuck, because if I read the blogs, I can maybe correlate with this. Yes, I see more reads, so maybe I should have a cache somewhere there, so 25 milliseconds sounds right. But again, I learn by building. I learn by getting my hands dirty. So what I really want is something like this. Has anybody seen this? No? It clearly shows how old I am, really. So back in the 90s, there was a really, really good game called Incredible Machine. It was pretty simple. You had all these kind of Rube Goldberg machines that you would build. You'd drop a bowling ball on a weight, on a balloon, the balloon would burst, and then you would kick off a torch showing something, and you would ignite a rocket and turn a switch on. But it was a pretty incredible simulation for something in the 90s, if you think about it, right? And my thought was, look, can't we have this for system designs? Can you actually build a system and see what happens, right? And that's kind of what I thought I would do. I spent a few months building this thing called SDL, a system design language lab. It's a DSL where you can describe your system, ask questions about where things are at, and look at what's happening in real time. Real time is a very hard thing. Look at what's happening, live, right? I'll show a demo soon, but I'll quickly walk through some of the high-level things. You describe your system like that. You say, hey, look, it's Bitly. I have 2 components, an app, which is an app server, a DB, which is a database. If you're programmers, if you've been coding, this looks like any other language, right? You have your class, you have your components in it. Then, okay, how do we talk about what's a database? What's an app server? All right, a database. A database has, by the way, how much database knowledge should I assume here? 0 is fine, 100 is fine. Show of hands, level of expertise, level of awareness. Okay, but you guys know what a database is. Yeah, that's good enough. So databases, you write data to them, you read from them, right? Databases organize data in various kinds of indexes to make your retrievals, to suit for certain kinds of workloads. You would use a hash index for getting key value lookups very fast. You'd use a B-tree index for range indexes, so for sorted, for sorted entries. For example, if I want to list all my contacts by their birth dates, that would be a B-tree index. If I want to get my contacts by first name, a hash index. So in this database, we have a hash index, component, which you write to. You would read from it, you write from it. That's it. And then your app server does something. It does something, it gives you back HTTP code, right? For these 2 APIs. And if you look at the shortened API, it looks at the database. It first sees if there's a duplicate, and then if there's no duplicate, then it'll insert it in the database, and then return back a code. All right? And similarly for the redirect, okay, I didn't put the redirect here. The redirect just looks at the index and gets you back a value. Now the first thing you'll notice is all this extra funky stuff, right? In this language, it's not a real language, by the way. This language is the most useless language in the world, all right? Anybody heard of functional programming? Okay. So the functional programming folks, for a long time, had a claim that they were the most useless language in the world, like Haskell, because it had no effects, right? Everything in functional language, their functions, you would model fx also as return values as opposed to actually changing some value somewhere. So they would proudly say they were pretty useless. I'm proud to say that SDL is even more useless than a functional programming language. SDL does not even have arithmetic in it, right? All it has is outcomes and distributions. So the idea is, if you look at the found duplicate, right, it's saying, sample the value for me, tell me if it's a duplicate or not. And that little bit of sample dist, blah, 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 tells you that there's a 0.01% chance that I have a duplicate URL ID, right? Now we'll talk about why that's important and why am I not just using a random value generator somewhere, right? So now with this, I have a stem here, right? And everything else should be taken care of for you. So first thing you get from this, because I've described my systems and components, is you get a architecture diagram. Not the prettiest. I'm working on that. I'm not a UI person. But it'll get better though. So it shows that there are three components with the redirect method calling the select method, which calls the find method. There is a shorten method that does its own thing. The next thing you get, you can generate traffic. Because as simulating traffic, we have a redirect generator at 1,000 QPS and a shorten generator at 10 QPS that does different things, and you can measure the different metrics on our system. So the two metrics here are measuring the P90 latencies, or the latency of the 90%, or the top 10% of the most heaviest requests at a given window. In this case, I think it's a 1-second window, right? Again, not accurate, but it's more about seeing how your system performs under various loads and scenarios. The screenshots are good, because I was scared about demos failing in an actual live setting. But let's see what it looks like in a real example. I chose Uber as an example, right? And, oops. So this looks like, so there's Uber, a more complicated example, right? Excuse me. So you have your various components, you have your, what calls they're making, which service they're calling, and I have a couple of metrics I'm measuring here. I haven't activated them all, but these are some of them, right? The interesting thing about this is if I was to change, let's say, how can I show this on the screen? Okay. So I'm moving that up here. So I can control this with a bunch of CLI commands. Implementate that, run this. Oops. Okay, all right, here we go. So that is generating a new baseline traffic for these guys, and you can see how it's changing. What's going on there? All I've added was an extra traffic generator at 20 QPS, and I'm seeing my system kind of change, the behavior changing in live. All right. Let's modify one of these. Let's modify one of the. Sorry, I'm not able to see my screen over there. Can you guys see the plus button over there? Okay. Oh, here you go. Perfect. Okay, if I change that, let's say if I change the yeah, I want to do this quickly. All right. So now you're going to see more, see how the system actually reacts to your latest parameters, right? You can see the utilization kind of go down as the number of ride requests are dropping, right? And you can do this for more scenarios. You can actually change your parameters. You can have more complex systems. You can measure different parts of the system, right? And see what's happening. You can actually validate your assumption on how you're preparing for your modeling, right? You can use this for actually doing your models too. If I was building a system, if I want to roughly see, how many instances of something I need on AWS, you can kind of use this, right? Now, this is not the most complex tool out there. There are amazing, amazing, amazing tools in every domain out there. But I found that a lot of them are kind of not easily accessible or just pluggable and use them, right? So if I want to do something, it gets me there, right? This is not a production-ready tool by any means. Using for some design interviews has been very helpful. But I would not today estimate your production load on your Kubernetes cluster using this, right? One day. So before I go to the concepts, any questions? Sorry? Cool. Yeah, so the key concepts, right? Okay. Yeah, so you have your components, the things that do things. You have your dependencies, which is who can talk to what. Obviously, the capacities are calculated when you set your different generators. In the diagram, you saw like, hey, from this node to that node, there was a QPS of 50 coming from there, right? So it does the flow analysis for you, right? And systems tell you, look, what's my overall system? So you can have multiple configurations, one with a cache, one without a cache, one with a load balancer. You can mix and match on your own, right? That's your ultimate incredible machine, right? Now, we talked about why are there no random numbers here, right? When you look at random numbers, they are very continuous, and there's infinite values, right? When we look at systems, we care about certain scenarios. I think one of the examples in Twitter was, if I had a large number of followers, what happens? And in a design interview, the actual number doesn't really matter. What matters is distributions. If I have less than 1,000 followers, less than 10,000, or if I'm Taylor Swift and if I had 1 million followers, right? Then what happens? So which means that I'm really looking at those three scenarios in more detail rather than exact number of 2,564 followers, right? So doing just on outcomes gives you a lot more control there. And if you really want to have more control, add more distributions, right? Or add more buckets. So having these finite discrete buckets means we can actually enumerate them, we can go through them, we can reason about them, as opposed to a fully, a mathematical function that's describing a probability distribution, right? And it makes our code completely explainable. Oh, sorry, our model is explainable, right? So I can take an entire system and at a glance, calculate what my ultimate distribution is going to be for any component, for any method, right? If I want more accuracy, add more buckets, right? It'll be slower, but it'll be accurate. It'll be reasonable. It'll be bound in a certain amount of time, right? So you can actually do things like, I'll pre-compute this for certain components. I can have a live thing on some components. The other important notice here is this is a steady state simulation. What that means is, it's not a, I mean, there are two main kinds, right? This is a steady state simulation and a discrete event simulation, right? The steady state, so the discrete event tells you, it's actually simulating the actual behavior of what's happening at any given point in time. So it might have its own internal state where if I see a user with this user ID, I'm going to do this. Or if a user has this kind of weight, I will do this, I'll write to that. And it's a very tight orchestration on a time boundary across many components, right? Now, that's fantastic. If you want accuracy, that's the way you should be going, right? What I chose to do here was go with steady state simulations. Whereas if I know that my component's characteristics are these, it has so much memory, it has so many cores, its network is 40% utilized. Then what is my performance at that point in time? Now you might be wondering, but Sri, isn't that really inaccurate? Isn't that going to be unrealistic? So the way I've been imagining is, by doing this, it's a lot more effective. I don't need to worry about orchestrating across multiple components at a time boundary. Which means that there's this lot of overhead in how you're managing priority queues and pushing and popping things out of all these different components coming out, like coming on top, right, and becoming ready. Now, a lesson or a trick that I stole from the functional programming guys world was, what if you can have both? What if you can have the steady state simulations signal what they want the next state to be, but don't actually act on it? So the cache might say, look, I'm at 90% capacity. I'm not going to actually start spilling. I'll signal that I'll spill, right? A second layer on top of that, call it the orchestration layer or the temporal layer or the stateful layer, right? You can take that signal and change the parameter on the component. You might say, look, after 5 seconds of running the cache on 4 cores of CPU, 8 gigabytes of memory, and 90% utilization, let me actually let me reduce the arrival rate to 5 QPS, and then see what happens. So now you get the best of both worlds without having to worry about the tight orchestration between these large number of components. Now imagine a cluster that is 1,000 components in size. Doing it in a DES way is going to be very, very slow. But this way, you can parallelize it and kick off a simulation of every component across a cluster of machines if you really want, right? And they're all independent simulations. So you can kind of get the best of both worlds there while not burning your cloud budget, right? You can also, the other thing is, I told you there's no math, there's no operators. I was half truthful about that. You could add in custom functionality using native methods or native components, right? So if you really want to sign or cost function, create one that returns an outcomes instead of continuous values. So you might say that my sign function will give me 20 values at different levels, as opposed to one continuous level distribution of numbers. Fun fact: who has played the first Doom game? Yeah, the first Doom. The first Wolfenstein game. Again, I'll talk about all these old games. Sorry about that. So the way they did sign calculations in that game was not by using a sign function. They actually had I believe it was 16-bit, a 65,000 entry floating point table where each value would correspond to one chunk of degree ranges, right? So sine of x was just look up into this table. Voila, right? It's amazing how you can steal so many good ideas from old games. And simple things like CLIs to kind of ensure you can kick off these commands. You can have recipes. You can trigger these simulations. It's nice to have. I do have async await support, so you can actually kick off things like fan-ins, fan-outs from the simulations and see what they look like. Those still to be tested to a certain level. Not a UI guy, but amazing what LLMs can do, help you in building UIs. So a lot more to go in building a better design experience. Couple of quick questions. As we spoke about the random values, why is it a DSL? It is a library, but wrapped on a DSL for easy inclusion in an external environment. The goal of this was so that I can actually embed this in another environment, like WASM or a C++ library or whatnot, right? These are all goals that I will get to, but yeah. We spoke about limitations. It's not a full-blown or even a real language. I think it's more about describing what's happening in the system without how or accurately talking about why, right? It's more about the why rather than what or how. Okay. It has more applications. Most obviously, it's for education, both from teaching how to do it as well as for those who want to evaluate newer models. This is useful there. Cost modeling. I'm building a system. What's it going to cost me over the next 1 year, right? Lot of things planned. Help, really appreciate it. And let's chat if you're interested. So I spoke about GenAI and how one of my first intuitions was, look, 2025, people want to hear about GenAI. Should I be making a talk that's not going to be about GenAI? And when I dug in, GenAI is fantastic. It's amazing for doing a lot of things, right? When we started those 3 plots, right, that's where we got stuck. But when I came up with the grammar for this language, and I fed that with a couple of examples back into GenAI, it was fantastic in coming up with those scenarios, right? Which meant that I didn't have to blow away tokens in trying to tell it, look, what I want the UI to look like. I can use a lot of, think of this as L1, L2 cache code, right? I can build all this stuff up, have GenAI talk the interface of this thing, and drive this. So now you can, if you truly choose, you can actually have an interview coach GenAI act as an interview coach that would push you towards, okay, now you did this, now try this. Well, now I'm seeing that. Oh, this is what's happening, right? So there's different horses for different courses. You want to use the right tool for the right job, right? One learning I had was, look, as engineers, we love building. It's tempting to kind of build more than necessary. So having a demo in mind and starting back was really, really helpful there, right? Sometimes I would do a thing that sounded really fancy and really cool, but when I saw the demo, it was like, that's not going to help in the demo at all. It's not going to help the user at the end of it, right? So let's see what the user is going to what the user expectation is going to be, and then start from there, right? Love CLIs, love text. I think it's very, very underrated. You guys should definitely, invest more into it. For those who want to learn more about the details, there's plenty of good stuff that I had a lot of fun going through. Most really important thing is queuing theory. I think system design interviews are, people don't say it, but I believe they are truly about queues and managing queues, right? Where things fail, it's a bad queue. How things fail, it's a queue. How much, how to spend, ask the queue, right? Yeah, so these are fantastic references that, at the worst case, you'll love it, right? One more thing that is really interesting. All right, any questions?
Maybe I said, but is there a repo?
Yes, that's the next slide. I don't want to, yeah. So yes, there's a repo. It is still very early stages. If you want to talk about it, give me ideas to share and collaborate. I would love to hear and learn from you guys all. So yeah. But yes, any questions?
What made you go down the path of defining your own language instead of starting with one of the many existing?
Yes, great question. So there's two parts to that, actually. So the question was, why did I create my own language? I'll start with the reason number 3, because it was fun. But more pragmatically, I tried a few languages. I looked at Julia, obviously Python. Now, for me, speed was something that actually was important. Right? Speed and embeddability were important things. So not being tied to one ecosystem was kind of key. There is the aspect of N+1 language here, right? So the other one was when I saw, by the way, there are actually some really powerful academic level probabilistic programming languages, right? That you guys should check out. Now, what I found was that what was in academia was what was easily usable. There was a big gap there. There was a language called, I think, Hakaru or Haraku, which was around modeling probabilities, right? And it was a full-blown language too. And I think what happened was that as the languages got more and more real and useful, the ergonomics were kind of hard for a demo, right? And also because and also these languages are also differentiable too. So they can actually work on actual probability functions that are mathematical and then work backwards. That made for a really hard demo, right? And teaching somebody the entire language first and then design was kind of 2 battles, as opposed to, hey, look, here's a design, talk in almost English what your design is, like DB talks to that talks to this, or calls this, calls that, and let's evaluate everything else. So the DSL is just a helper on the library, by the way. The DSL makes it easy to kind of have a text box on a web page that you can parse and send out, as opposed to having an entire language IDE. Yeah.
So what's been your experience with finding a user base that's trying this out and getting feedback?
Well, I'm starting it now because I've been working on this for about 2 months.
Okay.
So this is a very new project. I'm going to be, huh? So again, this is a passion project for me, right? It started because of my own failed interviews, and I love building, and I love simulations. And when I spoke to a bunch of people in universities and schools that wanted to use this, I wanted to learn, they found it useful. Fun fact, my kids who are in their teens or early teens, they're able to use this because it avoids all the programming that they don't want to deal with, right? So they found that, look, if I can describe a system and not worry about what's RAM, what's a for loop, what's this, what's that, I just focus on my behavior, or what the intent behavior is, it's easy for me to appreciate the systems. So school kids love it. Yeah. Any other questions? Yeah.
So going back to checking if a system is, answering the question, if this is a good system, what should I look for? Like if maybe if the system, if some component is going
Right, right.
comparisons with other systems. I mean,
Right.
like AI.
Yeah. So the question was, looking at this dashboard, I'm assuming, how do I know if this is a good design or not, right? I should show this guy. Yeah, is that a good design, right? And so think about your day job as an engineer or an SRE. You typically you're working at 3 a.m. because one of these graphs is off, and you're getting an alert, right? So when you are going to a design, you want to know, look, given what I know about my user base, and given what my projections are, what's going to break, what can break, right? So you start back with what are the acceptable levels for these different metrics, right? A database utilization of 100 is not a good metric. You may want to ensure that your utilization is always under 40%. So then, as you tune your various generators and traffic generators, right? You might say, look, even though the product manager didn't tell me that I'm going to have this on Christmas Day, the rush is going to mean that thing is going to spike beyond a certain amount. So my estimate is not quite there, right? Now, to your point, what you can do is look, hey, AI, take this. I'm seeing this spike up. Which component is the problem? How do I scale it? So you might say, look, the database needs a cluster, it needs sharding, it needs a load balancer. If all the requests are coming from Asia, then I might need a geo kind of handling of these requests. So that's the starting point of that investigation, right? But point is, you don't need to build that to kind of know that. You can do this and say, I can actually anticipate that on December it's going to happen. Oh wait, my design doesn't handle that. So what can I do? Or at least what can I put as a Q4 activity, Q4 OKR, to flag up my leadership chain so they can fund this, right? That's the manager and me talking. Yeah.
Have you, 2 months, have you had the opportunity to practice using this in the interview yet?
I did. There is a kind of bias there because I was building this while I was practicing and while I was going through it.
Sure.
I felt I was a bit more ready to begin with, right? But what I noticed was that I found this more fun for myself. Reading blogs, they're good. I mean, look, there are fantastic blogs out there. I'm not going to diss any of them. There's amazing ones. I'm not a passive learner, right? And same, like the next best thing was actually writing down and making my own calculations. But the fun part wasn't the math. The fun part was this big picture and then zooming in where I want to, when I want to, right? Doing that on a piece of paper wasn't as fun, I don't want to go the path of Cluey yet, or ever. To me, the fun is kind of where I'm looking at, right? So, yeah. And one day, maybe I'll even make it as pretty as this, I'll make it as pretty as this guy. That's probably not an open source image, though. Yeah. Any questions? Are we on time? All right. Thank you. Thank you for. Oh, sorry. Yes.
Just can you pull up the GitHub again?
Oh yeah. You want to see the actual repo or just? Oh yeah, sure. How do I do this? No, okay, sure. Oh, is it?
Quite possibly.
Oh, shoes. Okay, I will. Oh, you're right. It is private. Sorry, guys. So embarrassing. I promise in the next 5 minutes it'll be public. Thank you. I think what happened was I was building something else, and I refactored this repo out of that. And I think in that process it was just private. But I promise it is on. It's even on an Apache license. So, yeah. Yeah. Feel free to diss it, comment on it, anything. Cool. All right. Thank you. Thanks for,